Morning, everybody. Happy Friday and happy end of the first full week of class. Look, we've all survived. It's astonishing. All right. Lecture 5 today. Let's build some tables before that. Excuse me. I have announcements are usually at the top of the website, and I won't the homepage, and I won't read them out every single time. There is one announcement today to which I'd like you to pay some attention, and I had my GSIs send me the details. So, this is a very large class, and even in your lab sections, there are 25 people, and sometimes it is difficult to ask questions. It would be, for some students, it is nicer to be able to work in a much smaller group. And so we have that option to a limited extent, to the extent that we can staff it. And those are called tutoring sections. And so the tutoring sections work this way. You sign up for a slot in a week, and you can go and talk to somebody, like in a small group of 2 or 3, at that slot every week. Sign-ups are now available on Piazza. If you feel that that might benefit you, then please go. Sign up. And the object is to review some concepts from lecture and do a little worksheet if people are having trouble. So please do utilize the resources available. We try to make the best use of our staff time, so hopefully we will be able to keep this going, and hopefully that it will help some of you. So look on Piazza, and I will, once the homepage is updated, there will be information there as well. So small group tutoring is the new thing this week. All right. So, as always, we will start with a review of sort of one big topic that was covered last time. And last time, apart from going through some basics of different types of quantities that you work with in Python, we started talking about arrays. And an array is a sequence of objects of the same type. And in your head, it is very important from the point of view of data science to think of it as a column in a table. And we'll come to working with columns as arrays in just a moment. But think of it as a column. So, for example, if you have a table of, it represents some state, and the rows correspond to all the cities in the state, then the name column will have names, and everything will be a string. And the population column will have population size, and everything will be an integer, and so on and so forth. So all elements of array have a same type, and therefore you can do operations on each element individually. And you saw last time, if you have 2 arrays of the same size, you can add them both, you can multiply them both element by element. And what we didn't spend time on last time is that a column of a table is an array, and much time is going to be spent today on that. So that's a brief review of where we were. It is very useful to be able to refer in a compact form to ranges, that is, from this to that, without having to write the entire sequence out. So let's just do a quick run-through of that. I think you have seen this in your lab, but we'll just go through it anyway. And at this moment, what I'd like to do is I would like to take you through that top cell that I've never taken you through before. So Python has a vast collection of functions, methods, this, that, classes, libraries. And it needs to keep those all organized. And they're organized in what I call libraries. And so data science is a library that was written here specifically for the purpose of data science teaching. And it's an ordinary Python library. It's available to everyone who uses Python. And that first line says, from that library, import star everything. So from data science import star, you get that means that you have available to you all of the data science functions and methods. Now, of course, there are other libraries in Python. NumPy, numerical Python, is one of them. And when you use these libraries, you have to refer, when you call a function from these libraries, then you have to refer to the library so that Python knows where to look. And so when we call a function from NumPy, we have to say numpy dot something or other. And because we are lazy, we don't want to type out all of those letters. We just say, well, it's going to say NP. That's a standard abbreviation for NumPy. So it says import NumPy as NP. And we're going to use that routinely. And then the last 3 lines are to make plots look pretty. Library, that is a set of graphics routines. And that first line, inline, says do it within the table, don't give us a separate pop-up window. And then the rest says make them pretty. Not the default, do something a little bit nicer. That's what's going on there. So we run that cell because if we don't, then we don't have access to all of this, and then we get error messages saying a table, I don't know what a table is. A table is from data science. Okay, so I'm going to use a NumPy function, and I think you know this. A range, you've seen this in lab? Yes? Okay, so if we do this, what am I going to get? It's an array. NumPy will give you, NumPy is a set of array operations. It will give you an array, and that array will consist of the numbers 0, 1, 2, and 3. Remember we had this discussion, Python starts counting at 0. So when you say np.arange integer, you get 0 up through that integer. Except not including that integer. So you always include the left side and not the right. So let me just give you one which has, you can call it with 2 arguments, np.arange, how about 5 to 26. If you just say that, you get the numbers 5 through 25. So including 5, but not including 26. And it's going up by steps of 1. That's the default. If you want, you can go up by even steps of any size that you provide. So if I go up by steps of 10, then I will start at 5. I will add 10. I'll get 15. I'll add another 10. I'll get 25. And now I'm beyond the range, so that's what I will get. Just to make sure that we are okay with the difference between these two. Does not include the endpoint. Right? So the sequence is the starting value, the sequence of arguments is starting value, ending value, step. And it will go up to, but not including, the ending value. And so if you say, okay, I want the 25, so I know that it won't include the 25 if I just say 25 as the last point. So what if I just went a smidgen over 25 at the ending value? Let's try that. Should we try that? Type in the function, come on. So you did get the same values, but now they're floats. Right? Because you put in a float at the end, and so it's going to give you back floats because you're sort of in float world. Okay, so far? And we're going to need this because sometimes we're going to say, look, I want the following rows of this table. I want rows 17 to 48. And you just want to be able to put in 17 to 48 and not have to write 17, 18, 19, 20, etc. All right. So ranges, consecutive numbers, you have several different calls. If you just give it the end, it will give you an array of increasing integers from 0 up to the end. You can do start, end, you can do start, end, step, and it always includes start but not end. Okay, time for tables. So far, when we've worked with tables, I've just said, okay, I've got this table sitting in my environment and I'm going to work with it, but of course we have never actually gotten hold of a table from elsewhere. And so there are a couple of ways of doing that. Ways to create a table. Okay, so the most common way is to read it from a file. The syntax we will do in a demo in just a moment. The most common way is to read it from some spreadsheet or file that's sitting elsewhere. And the second is to actually construct it from scratch by yourself, by typing in its entries. You can see that is less common because you will typically not be typing in entries if you can help it. If you are developing the data set yourself, then you probably will be. If you're collecting the data, which sometimes happens, some of the connectors have done that. So those two, the top two, are for starting out, getting hold of a table. But you know from our lectures in the previous couple of lectures that if you use the table methods like select and sort and where and so on, they also generate tables. Drop, all of those create tables, but they create new tables from existing ones. Questions so far? Can we do a demo? This is an empty table. Capital T table, nothing in parens. You see anything? No, because it's empty. Okay, so what I'm going to do now is I am going to start with this empty table, that's a starting point, and I am going to append to it a column. Basically, I'm going to give it a column. To give it a column, I need first what the column is going to contain, and my example is going to be the streets that are south of campus. And so I will make an array consisting of, well, let's go in order, Bancroft, Durant, next. Good? Okay, so that's an array. And what I'm going to do is I am going to take my empty table and create a new one with the column. So with column is the method. I have to give the column a name. So with column takes two arguments, label, array. So how about we just call them streets? I'll call the thing street, and the array of values, what have I done? Streets. And now I have a table. This table is wonderful. We're looking at it. If I want to use it, it doesn't have a name. I have to create it again. So why don't we call this, I don't know. If I do that, then I can't see it. So far, so good? All right. So let's add another column. Why don't we take this table and then append to it a column called blocks from campus. Good, I've just made another use of with column. Important thing to note about with column is that it doesn't change your original table. If I now call Southside, if I now ask for Southside, it still only has streets. This is a little temporary operation that I've done. If I want to use the bigger table, I need to give it a name, right? So you could say Southside with blocks. You could also just change Southside by attaching this new table to the same name. Okay, I'll stop and take questions. Yes. Okay, when you're importing a spreadsheet, is it restricted to any type of spreadsheet? Hold the question. Could you please ask again when we start importing from spreadsheets? That's a good question and an important one. But please, if you will remember, because I won't. Thank you. More questions? Now, yes. Can you add rows? You can. Give me until the end of today or the start of Monday. You can add rows. You can also add more than one column at a time. Good? So far? All right. Yes. What happens if you add a column that doesn't have the same number of rows? Well, we can do that. So why don't we do south side with, sorry. How about that? Good? Column length mismatch. More questions? Yes? Once you rename the table, it is those values for the rest of your notebook. You can go back and construct it again if you want to go back to the old thing. All right. And so we will now come to reading a table from a file, which is the standard thing that we do. And so it's just because I can never remember what the tables are called. I have a file sitting somewhere, and these files that you use will in your labs and so on will be sitting in a place where your notebook knows how to access it. So the file has this funny name, and to understand where that name came from and what is going on here, let's just go and take a look at what Minard is. Okay. Minard was a Frenchman who has one of the great examples of data science. And you can see that I have this, I'm determined to remind you that data science isn't something new that we just invented. He has one of the greatest examples of visualization, still considered one of the greatest examples of visualization ever. And what he was doing is he was making a visualization of Napoleon's disastrous Russia expedition. So in 1812, Napoleon's armies set out for Russia. Rather unwisely, they chose the winter weather. And Russia is no fun in the winter if you're not prepared. And so bad things happened. This visualization in one simple map displays 6 variables: the number of soldiers, the direction of the march, the latitude and longitude. So 1, 2, latitude and longitude are 2 variables. The temperature on the return journey, it was cold. And the dates in November, December. Let's take a look at a map. You have seen John Snow's map. That is one of the classics of data science, and here's the other one. Okay. Beautifully hand-drawn, just exquisite. Okay, so let me tell you what's going on here, right? There's a march. You are starting here, and you're ending up right there is Moscow. All right, the army goes to Moscow and comes back. Along the bottom, and this will make, you will be able to see it much more clearly when you're actually looking at your textbook. There is, so time goes that way and also this way in a way that I'll explain. There's temperature and there are months, so I can see December over here, December. Okay, and somewhere there's a November, which I've here. November right there. Okay. The tan band up there is the direction moving forward, heading towards Moscow. At every point, the width of the band is the number of soldiers at that point. The black band is the retreat from Moscow. I will now pause and take a look at that. That's a sad story. Look at the width of the tan band, the army that starts out. They go, and then at a point they branch off. There's a little branch that goes up there and then comes back, and it just hangs out over there at Polotsk. Okay, so the army continues, but the band is growing smaller every time. They're losing people, right? They go to Moscow, doesn't turn out so well. They've got to come back. They start coming back, and the place that is really quite heartbreaking, so they're coming back, and those people who are up there join them right here. Yeah? And now look, here is the river. This is a river. Let me show you a pointer. This is a river. It's right here. This is November, December. That decimated army crosses the river, no boats. What happens? Even fewer. And only that small fraction return. So this map has the virtues of visualizations that are simplicity. There's not a lot of bells and whistles, not a lot of colors to distract you, and ingenuity of design. It's the width of the band and the two colors going forwards and backwards. All right, so what we are going to do, so this is due to an engineer called Minar, and what we're going to do is look at some of his data. Before I do that, questions? Okay, so that's where we were. Okay, that is why my file is called minar.csv. That's comma-separated values. It's a spreadsheet. You can read it into Excel. You can use any table like an HTML table or anything. You can use anything that has a reasonable table structure. You can use. So this is a file name, hence it's a string, and I have to give it as a string in quotes. So I read it, so table dot, and the method is read table, straightforward. So you read table, and I've assigned that to the name Minar for obvious reasons. So I run this cell, and I look at the table, and it's just a very small subset of the values that were plotted. And so you're starting, the starting point of this table is you're going from Smolensk to Moscow, and then you're coming back. So there's an advance, and then there's a retreat. And you can see that at the advance, at the initial point of this table, there were 145,000 people, and at the end, there were merely 1,200 people. And so what we're going to do now is we're going to do a little bit of work with the values. So you know already this method. That just selects the column. What I'm going to do instead is I want to work with these numbers. In particular, I want to work with this initial value, 145,000, because I want to convert all the others to percents relative to that value. So I want that value as a number. This doesn't do it for me because what I've got is a table. If I do instead, I get the numbers as an array, and now I can do array operations on this. All right, so sometimes when you want to do math with a column, it is useful to get them out as an array. And the important thing here is to note the distinction between select and column. One gives you a table, and the other one gives you an array. Okay. So do you remember how from an array we can get a particular value? What's the function? Did it last time? Yes. Item, terrific. And so these are all items of the array. Thank you very much. And items are labeled by index. And what are the indices here? 0, 1, 2, 3, 4, etc. So if I want that 145,000, then what? No, come on. Column. Much better. Extract the column as an array. Get the 0th item of that array. Questions thus far? So now what I have is a number that I can use, and I'm going to give it a name. So now that I have that, what I'm going to do is I'm going to take my array of survivors, and I'm going to look at it relative to that initial value. And because that column is an array, every element of the array gets divided by that initial value, which is why the first element of your result is 1. And the last element is the proportion that were left at the end. So you start with 100%, and you end up with a mere 8% of the people left at the end. Now, this is all fine, but what we'd love to do is we would love to see this as part of the table. Otherwise, it's very hard to keep track of everything. So let's give this a name. Actually, I will leave this cell untouched so it remains in your notebook, and we will do that. And then we will we will add to Minar a column. Okay, so we have now a new column, but there's kind of an annoyance. I've said percent surviving. Those things are proportions. I'd like to show you that when you have numbers and you want them to look pretty, you can use something called set format. So it's the percent surviving column that I don't like. I want it represented as percents. Ooh, much nicer. So this is a little numerical encapsulation of what you saw in the picture. I just want to point out that this is the percent formatter is merely display format. If I look at the numbers in the column, they are still the proportions that you put in before. Now, you notice that we keep typing in column labels. It's sometimes a little irritating when the labels are long. You can refer to columns by their index. So, for example, index 0, 1, 2, 3, etc. And so if you look at minar.column 2, you get the array of all the cities. You don't have to type in city. That saves you a lot of work. When your notebook scrolls upwards like that, it is easy to forget what the labels were. So, of course, you could scroll back, but you can also figure out what the labels were, and they come out in order, and it is very helpful. It is particularly helpful for me because I never remember what was capitalized and what was not. You can figure out the number of rows in the table. There are 8 rows in the table. Do we agree with that? Yes. And you can figure out the number of columns. These are sort of basics that you can do. Good so far? Yeah. All of the data was extracted from that image? That's the question? Yeah, so basically those were the data that, it was part of the data that were used to construct that image. So I think some human did that. Some human took, I think it was Minar, I think his actual data exists. Right? So that data was done in a table. We didn't feed a map into Python and say extract numbers from this, though no doubt that is possible. Yes? Is there a way to change the order of the columns? There is one thing you can do. So let's look again. You can move something to the start. So minar.move to start. I don't know. Let's see what happens. And you can move to N. You can mess around. Yes? Is there a way to keep the percentage? Yes. So I think let me just make sure I've got your question. So these things appear as percents, but then when we looked at the column, it was still proportions. If I want those numbers to be percents, I actually have to take them and multiply by 100. Okay, so here were Minard's data, and we have gone through this. So there are some table methods that we've discussed, creating and extending tables. You've got with column, read table, num rows, num columns. Labels and relabels, you can change the label of a column. You want to see us do that? Let's just go through the rest of these. Column takes a label or an index, returns an array. You can do item, sum, min, max. Once you've got an array, it's just an ordinary array, and you can do whatever you wanted to do to arrays. Okay, so select, drop, etc., create new tables that have the old tables. We already know this. One thing you may want to do is sort of minar.relabeled what? Percent surviving. What do you want to call it? Okay? Now, This is a whole, again, it's a laundry list of methods. You're not expected to have all this memorized. You just know that roughly you can do these kinds of things. And hopefully we have a little time later. We can go back and look at the data science tables documentation, and there's the entire list of what you can do. So you can go and mess around to your heart's content. What I would like to do now is I'd like to take a slightly bigger data set and work with it and extract some things, look at some visualizations, and look at some methods involving rows, as was asked here. So we've done all this. Okay. It's Friday. Let's go to the movies. I have this very long file name to remind myself what on earth is in that file, and so I will read that in using read table, and we will take a look at this file. And what this is the... Actually, let's look at all of them. It is for every year the average movie ticket price in the United States that year, the total amount grossed by all movies. This is in millions of dollars. So we are now up at, 11 billion? Yes? So that's a lot of money being represented there. The number of movies released that year, this is in the United States, and the number one movie of that year. So you can take a look at that for a little while, and you will see many movies whose names you recognize. Please note that this 11 billion is not the amount that Star Wars grossed. It's the total that all the movies grossed that year, all these 702. I want to show you, I came to Berkeley in the early 80s. I want to show you what I was paying to go to a movie. Yeah, oh, those were the days. $3 for a movie, yes. $300. I rented a one-bedroom apartment, nice near to campus in Berkeley. Oh, those were the days. All right. So what we're going to do is we are going to look at this. And what I'd like to do is I'd like to use these data to figure out roughly how many tickets were sold every year. I've got the total amount of money that was taken in from tickets, and I've got the average ticket price. What do I do to those to get some sense of how many tickets were sold? Just divide, right? Take the total amount of money, divide by the price of one. You should get the number of tickets sold. Now, it's going to be a very rough average, because that average ticket price is just an average. And there are probably some issues as to exactly how this number came about, but we can do it anyway. So, okay, I am just going to, so that I'm not having to scroll through, I'm just going to look at the first three rows now. Okay, so here we go. Estimated tickets. Okay, so what do I have to do? I have to take movies, the total gross column, yes? I have to be a little bit careful about this. This is in, I have to be careful about units. This is in millions of dollars. This is in dollars, right? They better both be in the same unit. So let me convert this to dollars. What's $1 million? 10 to the 6, yes? So that gives me raw dollars. And then I take this and I divide element by element. Before I run that, anything there I need to fix? I've extracted the total gross column as an array. I've converted it to single dollars, not millions of dollars. And then I've taken that array and line by line, I am dividing by the average ticket price of that year. And so let's take a look at what we got here. So we augment the table. Okay, Lots of tickets sold. Lots and lots of tickets sold and scientific notation, and that's all very well, but it's really hard to make sense of that. So we had percent formatter. We also have number formatter. That's a little nicer, and I have something to say about that number. First, it's an estimate, yes? Second, it's huge. Therefore, those decimal places, 0.01, 0.06, it's all nonsense, right? You should not be thinking that you've got some hugely accurate estimate. It's just because you divided one big number by some other number that had decimals in it, those numbers, those things at the end don't make any sense at all, right? You just have this sense that there were, 1.3 billion tickets, roughly, in the year, in the year 2015. That's what we're estimating. So far, okay? You can draw pictures. And it's when you have years like this, so in sequence, it's very common that you are going to want to draw what is called a time series, just a plot of something against time. And so what I'd like to do is I'd like to draw a plot of the number of tickets against time. And you take your table, and the table method is plot. And you specify not age, year. You specify what you want on the horizontal axis as the first argument, and what you want on the vertical axis. So this is the estimated number of tickets sold, and let's see what you get. That's the plot that you get. And those numbers are all in the billions, and so you have scientific notation up there, and you've got the years going along here, and I just want to take just a very rough look at this picture, and I'm really interested in that peak. That peak is somewhere in the range 2000 to 2005. Agreed? Should we take a look at the peak? There is one thing that I want to point out. If you get tired of typing labels, then you can type indices. So movies.plot year was index 0, and this was 0, 1, 2, 3, 4, 5. And you get the same plot. It's a little harder to read your notebook afterwards, but it's sure less typing. Okay. So what I'd like to do now is extract the rows corresponding to these years. And so, where? Year. Now, haven't we used where before? Right, we've used where when we wanted to extract, like, say, a particular year, when year is equal to something. But now we want a range. So you can specify conditions to be satisfied as in the following way. Where the rows are satisfying something, and so why don't we do R between 2000 and 2005. Just watch what happens when we do that. The first thing you note is you got a new table. Like where? It returns a new table without messing with the old. It has given you the rows where the column year has values in that range, consistent with Python, starting at 2000 and not going up to 2005. And what we can see is that the big jump is the Spider-Man year, 2002. If you want just the Spider-Man year, you can do another way of using R equal to, what is it, 2002. Just this and that is the same as what we had done before. If you don't say anything, it's just going to look for that particular value. 2 ways of getting a single row with a specified value. You can use one of the R options, or you can just specify the value. I would like to take a look at the Harry Potter movies. And so if we look at movies there's no way I'm going to remember the titles of the Harry Potter movies. So, where? Okay, I'm going to look at when the number 1 movie was a Harry Potter movie. So when the number 1 movie, and now, I know that the name is going to have Harry Potter in it, I just cannot possibly remember the rest. So R containing the string Harry Potter, and look at that. What is being displayed in this table? It is the number 1 movie of the year. The very first Harry Potter movie, that one, everybody went to see it, right? Everybody saw their first Quidditch game. It was all very exciting. Then, there were many, many Harry Potter movies. And yeah, they did very well, but they were clearly not the top movie of their year. But then everybody went to see the last one. So the main point here is that you can put in R containing, and if you have just some little bit of your string, then you don't have to type in the entire string. Questions thus far? A couple more things to show you. There are lots of ways of using R, year. R below, there's R above. I want to leave you with one thing. What is where doing? It is giving you a new table with rows corresponding to with the rows that satisfy the condition that you have stated. Yeah? So that means there's a condition. But sometimes you might just want to take rows 5 to 10. Okay? Take rows 5 to 10. There's no condition. I just want 5 to 10. Just take 5 to what? 10? 11, so that I get. Please note that these are row indices 5 to 10. Row indices also start at 0. Okay? So you're just going to get used to counting from 0. All right, I'll see you Monday. By the way, attendance. So, whoa. Settle down. Attendance. We give you attendance credit if you have attended 2 out of 3 lectures. Yes? Monday and Wednesday, you already attended. We're done. That's why I didn't take attendance today.